So, hi everyone, this is Dr. J. Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So, we are discussing numerical methods and integral transform course. In that course, the first concept is interpolation. In the interpolation concept, we are discussing Lagrange's interpolation. So, in this video, we will discuss Lagrange's interpolation formula, when we can apply this Lagrange's interpolation formula, and then we will take some problems on the Lagrange's interpolation formula. So now, in the previous videos we have discussed Newton's forward interpolation, Newton's backward interpolation, Gauss forward and Gauss backward interpolations. All these interpolation formulas are used whenever the x values are equally spaced. So this is one example here. So these are the values of x we have taken, 1, 2, 3, 4. Now you take the difference between these two values, 1 and 2, the difference is 1. Next you take the next one, 2 and 3, the difference is 1. Next 3 and 4, the difference is 1. So whenever we are having a common difference between the values of x, then you can use this Newton's forward, Newton's backward, Gauss forward and Gauss backward interpolation formulas. So next one is, suppose if the x values are unequally spaced, that means this, if you find out the difference between the values of x, if you have unequal difference, so then whenever we are having this type of situation, then we can take the help of this Lagrange's interpolation formula. So this Lagrange's interpolation formula is used when the x is unequally spaced. Now we will take what is meant by unequally spaced. So now these are the x values I have taken, 1, 2, 4 and 7. Now if you take these two values 1 and 2, the difference is 1. And if you take next 2 and 4, the difference is 2. So when we take the first two numbers, we are having a difference 1. When you take the second number and third value of x, we are having a difference 3. So it is very clear that we have unequal difference here. The difference is not equal. So whenever the given data having this unequally spaced between the values of x, then these above formulas interpolation, Newton's forward, Newton's backward, Gauss forward, Gauss backward interpolation formulas are not applicable. So in this case, we have to take the help of Lagrange's interpolation formula. So once again I will repeat, this Lagrange's interpolation formula is used whenever the x values are unequally spaced. That means whenever the x values has unequal difference between the values of x, then we can choose Lagrange's interpolation formula. Now we will go for the Lagrange's interpolation formula. So this is the data given in the problem. So x values, generally the x values are generally represented with x0, x1, x2, x3. For example, we have taken this table and its corresponding y values are represented with y0, y1, y2, y3. Now for this data, we are going to take the Lagrange's interpolation formula. Now we will see how to take the formula from this data. So y of x is equal to, so now while you are taking the first term in the Lagrange's interpolation formula, you concentrate on x values here. The initial value of x here we have represented with x0. For some time you don't consider this x0 here, you start with x1. Okay, so now, so after neglecting this x1, the first value of x is x1. So you take x minus x1. Next you go for the next one, x minus x2. Next x minus x3. Okay, so this is the way how we can get the numerator in this Lagrange's interpolation formula. After taking that numerator, now in the numerator wherever you are having x, you replace that x with x0, which is neglected in the numerator. So in place of x we have taken x0. So x0 minus x1, x0 minus x2, x0 minus x3. So this is the difference in the whatever in the numerator we are having in terms of x, whereas we are replacing that, we take the same to the new denominator, and in the denominator replace x with the value which we have neglected here. So our neglected value is x0. So in place of x, we take x0 minus x1. So here in the second term, take x0 minus x1, and here also replace x with x0. So after doing these small modifications to the numerator, we will get our denominator, and you multiply this value with the corresponding value of y. So our corresponding value of y at x is equal to x0 is y0, or we can take this way, this y0 we can also represent it as f of x0. So in this way also we can represent this one. So now we have neglected, by neglecting this x0 term, x0 value in the numerator, now we got this first term here. Now we will go for the second term. So now whatever the value we have neglected at the initial stage, now you consider that, or now you neglect this x1 value here, that is second value, in order to get the second term. So now take the same one. So x minus x0, consider the first value of x, that is x0, and now we are neglecting this x1 here, so don't consider this x1. So after taking x0, immediately go for this x2. So x minus x2, and then go for the next value, that is x minus x3. So now in place of x, you replace that x with x1 in the denominator. So replace that x with x1, x1 minus x0, x1 minus x2, x1 minus x3. So after taking this denominator, take the corresponding y value for x is equal to x1. Now you consider this y1 value, and you multiply this y1 here, or we can represent this value as f of x1. So like this, by each time by neglecting one value of x, we will get the corresponding terms here. And similarly here, I have neglected, now I have considered this x0, x1 value here. Now if you want to go for the next term, you neglect this next value of x, that is x2, and you start with x0, x1, x3. So x minus x0, x minus x1, x minus x3. So here we have not taken x2 here because we have neglected this x2. Now take the same numerator to the denominator and replace x with the neglected value of x, that is x2. So in place of x we have taken x2, in place of x we have taken x2, and in place of x we have taken x2. And now multiply this fraction with corresponding value of y, that is y2. So like this we can construct this our Lagrange's interpolation formula from the data, from the given data. So like this we can continue. Suppose if you have x4 and its corresponding value is y4, then we can take this next terms here. So here we have taken this formula up to x cube, x3. So we have taken these terms, 3 terms, by neglecting one value of x. Okay, so this is our Lagrange's interpolation formula here. Now this once again I am repeating, this Lagrange's interpolation formula is applicable only whenever the values of x having unequal difference between them. Okay, this point we have to remember whenever we want to apply this Lagrange's interpolation formula. Now let us take one example for this and how to substitute that values from the table here. So now our first problem is use Lagrange's formula to calculate f of 3 from the following table. Okay, so here f of 3 is of the form f of x. So now compare these two, we can get our x is equal to 3. Okay, so no need to check whether this x is equal to 3 lies at the beginning of the table, ending of the table, or middle of the table. That concept will not be applicable here. So wherever that x value lies in the table, then directly we can go for the Lagrange's formula and we can find out our required value. Okay, now this is our formula here. So you take this one as x0, and this is x1, and this is x2, x3, and this is x4, and this is x5. So f of x is equal to, or we can take y is equal to f of x, or f of x is equal to. So first, as usual, as we discussed in the previous slide, first we will neglect this x0 and we will start with x1. So x minus x1, x minus x2, x minus x3, x minus x4, so x minus x5. So x5 is our last value, so we have to take up to x5. And similarly, replace take the same numerator and in the denominator and replace x with x naught. So like this, take the formula. So we have to take up to f of x5 because we are having up to x5 values of x. So now one by one, in each term you substitute the value of x here. Our x value is x is equal to 3, and whatever the values he has given in the table, in place of x1 replace that x1 value, in place of x2 replace that x2 value, x3 value, x4, x5 values, and its corresponding y values are represented with y0, y1, y2, y3 and y4, y5. So this f of x naught we can represent it with f of x naught is nothing but y0, f of x1 is y1, and this is f of x2 we can represent with y2, and so on, f of x5 that is represented with y5. Now substitute these values in this table, in this formula. So this, take x is equal to 3, already we have discussed x is equal to 3. Now substitute all these data values in this standard formula. Now simplify this, all the values, all the terms, then finally we can get f of 3 is equal to 10. This is very simple, just whatever the data has given, we can use that data directly, we can substitute that values in the formula, and if we calculate this, simplify this, we can get our required value of y at the given particular value of x. So this is the way how we can apply this Lagrange's interpolation for the given data. Now let us take one more problem. So one more model. So now here, this is the second example, Lagrange's interpolation formula. So we have to find out the Lagrange's interpolation formula, and after finding that Lagrange's interpolation formula, from that Lagrange's interpolating polynomial, we have to find out the value of f of 3.5, which is not given in the data. So this type of problems you may get in the exams. So find the Lagrange's interpolating polynomial for the following data and then evaluate f of 3.5. So the first one is, this is the first task, finding the interpolating polynomial, and the next one is using that interpolating polynomial. The second is finding f of 3.5. Some of the students, they feel that they will not find out this interpolating polynomial directly, they will consider this f of 3.5, which is of the form f of x. So directly they will substitute x is equal to 3.5 and they will find out f of 3.5. That is not the process here. First we have to concentrate on the polynomial. In that polynomial, substitute x is equal to 3.5. That is the meaning of this problem here. So as usual, you represent these x values as x0, x1, x2, x3, and its corresponding y values are y0, y1, y2, y3. So now if you find the difference between this here, we have a common difference, no problem. Even though the function, if you have a common difference between the values of x, we can also find out this Lagrange's interpolation here. So no problem. So in the problem itself, we mentioned that name of the interpolating polynomial. So we can use this Lagrange's interpolation polynomial. So here we are having x3 up to x3 and its corresponding values are y3. Now first take the formula as usual what we have discussed. This is our first one. We got this first term by neglecting this x0. Now take the second term by neglecting this x1 and by considering this x0. Now take the third term by neglecting this x2 by considering x0, x1 and x3. We got this term, and finally neglect this x3 value, x3, and you consider x0, x1 and x2 and its corresponding y3. So this is the formula here. So the important thing is, whenever we want to find out the interpolating polynomial, so don't substitute anything for x here. So keep that x as it is in the formula. Then only interpolating polynomial is nothing but finding the relationship between dependent and independent variable, that is y is equal to, we have to get that y value in terms of x. Okay, if you want to get in terms of x this y value, no need to substitute anything for x. So keep that x as it is, and the remaining values you substitute from the table. So I have not substituted anything for x. So I have substituted remaining values: x, x0, x1, x2, x3, y0, y1, y2, y3. So now you multiply these two terms and simplify here. So you will get, if you multiply x minus 2 into x minus 3, x into x, x square, minus 3x minus x minus 2x, that is minus x, minus into minus. So we know how to multiply these two factors, and then you will get the remaining one is x minus 4. Like this, you simplify this, you will get this value. Now once again you multiply this x minus 4 with this, we will get our required polynomials here. Now take the common terms and simplify, you will get our required polynomial by simplifying this. So we know how to simplify this. First you concentrate on x cube term and calculate this x cube term. Next you concentrate on 9x square terms, x terms and constant terms. So finally we get a polynomial f of x that is also represented with y. So y is equal to x cube minus 3x square plus 3x. This is the value, this is the polynomial we get in terms of x. So the process of finding the polynomial, whenever we want to find out the polynomial, so the first important thing is don't substitute anything for x. Except x value, you can replace all these x0, x1, x2, y0, y1, y2, all these values from the table and simplify, you will get our required polynomial. So now after finding that polynomial, he has asked to find out f of 3.5. Now directly, so here we want f of 3.5, but here we got f of x. So if you want to get f of 3.5, put x is equal to 3.5 and simplify this. So f of 3.5 x cube, replace x with 3.5 whole cube minus 3 into x square, 3.5 x square. Now if you simplify this total, you will get this value is equal to 16.625. So this is very important thing, how to find out the interpolating polynomial here. Okay, so now in this video we have discussed Lagrange's interpolation formula, when we can apply this Lagrange's interpolation formula, how to apply this Lagrange's interpolation formula. So in the next video, so with this concept we can complete our interpolation concept. This by completing this Lagrange's we can close our interpolation concept. So in the next video we will go for the curve fitting. So what is meant by a curve fitting? What is the method of least square approximation? By using the method of least square, how to find out the curve for the given data. All these things we can discuss in the next video. Thank you.